Our digital world is just exploding. We're talking trillions of dollars in assets being created, traded, and stored in a space that it's more valuable and, frankly, more complicated every single second. So, how on earth do we protect it all? Let's dive into the story of this massive digital boom and the race to build its ultimate vault. So, just to get a sense of the scale here, check this out. An estimated 559 million people around the globe own some form of cryptocurrency. That is a massive, massive community, all built on digital trust. And it's really just getting started. But the number of people involved, that's only half the story. The real story is the value. The global crypto market is on track to hit nearly $8 trillion by 2030. That's just an astronomical amount of wealth being secured by, essentially, digital keys. And this isn't just happening in one corner of the world. What's so wild is where this is happening. I mean, look at this list. Turkey, Brazil, South Africa, the Netherlands. High adoption is popping up everywhere. This is a truly global financial revolution. But, with all this incredible growth comes a pretty serious question. As we're building this incredible new financial world, there's a storm brewing on the horizon. A new kind of computing power that one day could make all of our best defenses, well, basically useless. Right. So what is actually standing between all that value and someone who wants to take it? The whole thing hinges on the digital locks that we use for everything online. And that lock has a name: cryptography. It's the mathematical backbone of pretty much all of our digital security, protecting everything from your bank account to your Bitcoin. See, it's built on math problems that are just ridiculously hard for today's computers to solve. But what happens when a totally new kind of computer comes along? And this is where the problem really comes into focus. Classical computers, the ones we're all using right now, are amazing, but they have their limits. Quantum computers, though, they play by a whole different set of rules. For certain jobs, like, say, breaking the encryption we all rely on, they could be exponentially more powerful. Powerful enough to just shatter the mathematical locks we thought were unbreakable. So, if math alone isn't going to be enough to protect us, what will? Well, the answer might not be to build a harder math problem. The answer might be to change the rules of the game entirely. We're talking about a new kind of security, one based not on how hard a problem is to compute, but on the fundamental laws of physics themselves. And this quote from the research paper, wow, it really gets to the heart of it. Scientists are working on something called Device-Independent Quantum Key Distribution, or DIQKD for short. It's basically a way to create a secret key between two places that is as secure as the laws of physics will possibly allow. And this isn't just some sci-fi theory. This is what it actually looks like. Look at this setup. You've got lasers, optical fibers, detectors, and it's all connecting two individual atoms. They are literally building the foundation of a physically secure network, one atom at a time. So, how do they do it? Okay, so here's how it works in simple terms. First, they create this really weird quantum link between two atoms using light. It's called entanglement. Think of it as a kind of spooky, invisible connection. Second, they use the perfectly correlated properties of those entangled atoms to generate a random secret key. And third, and this is the magic part, they run a physical test. It's called a Bell violation check. And it proves, with the certainty of physics, that nobody is listening in. Any attempt to eavesdrop would literally break that spooky connection, and they'd know instantly. And this is the part you really need to get, because it's a total game changer. With this system, it does not matter how powerful an attacker's computer is. It doesn't matter if it's today or 100 years from now. The security is not based on a hard math problem. It is guaranteed by the physical nature of reality itself. It's a completely new way of thinking about security. Okay, so this sounds amazing in a lab, but could it work in the real world? Absolutely. The researchers proved that this quantum link could be maintained over 100 kilometers of optical fiber. That's more than enough to secure communications all across a major city. Now, I know graphs can look a little intimidating, but this one is the smoking gun. See that purple line? That shows the strength of their quantum connection. The dotted line at 2.0, you can think of that as the absolute speed limit for our normal classical world. Anything above that line is only possible in the quantum realm, and since their results consistently stayed way, way above it, it is undeniable proof that their system is truly quantum and therefore truly secure. All right, so it's secure, but can it actually do anything useful? Can it make a key? Yep. This chart here shows the actual rate they were able to generate a secure key over an 11-kilometer link. Now, it's not super fast yet. The shorter bar is the real-world rate, but the point is, it works. It proves this system isn't just a possibility. It's a practical reality. And get this, they left this thing running for 26 days straight. And at the end of that marathon session, they had generated enough secure data to create a 135 kilobyte key. That is a tangible, usable secret key created and verified by nothing less than the laws of quantum physics. Okay, so this is obviously a massive achievement, right? But what does it all mean? Well, this is way bigger than just one experiment. This is the groundwork for a whole new era of digital security. Because let's be clear, this is not just about protecting your crypto wallet. This is a foundational building block for a future quantum internet, a network where our most critical communications for finance, for government, for healthcare could be, for all intents and purposes, fundamentally unhackable. And this one breakthrough, it's like a key that unlocks a whole bunch of other incredible technologies. We're talking about creating perfectly random numbers, which is huge for security. We're talking about ways to test and verify that quantum hardware is actually doing what it's supposed to. This is the launch pad for so much more. So it really leaves you with this one kind of profound question. We built our entire digital world on the logic of mathematics. But as the stakes get higher and the threats get more and more advanced, we might just find that our ultimate safeguard, our final guarantee of trust, doesn't lie in the abstractions of code, but in the unbreakable laws of the universe itself.